As far as we can see across the universe, there is nothing that resembles the universe's edge. The only known limitation of our universe is the amount of it that humans can witness. For instance, physicists believe the universe's age is not limitless. The universe is believed to have begun 13.8 billion years ago with the Big Bang, which is why we can't see the entire cosmos because light has only had 13.8 billion years to travel, making up the entirety of what is viewable. But what lies beyond this visible bubble? Galaxies as far as the eye can see? Or does the universe have a definitive conclusion? A century ago, two brilliant scientists, Harlow Shapley and Herbert Curtis, met in the auditorium of the Natural History Museum of the Smithsonian Institution in Washington, D.C., to argue about the straightforward question, how large is the universe? Notably, this conversation occurred before Edwin Hubble identified the nature of galaxies. Curtis believed that the cosmos may be composed of numerous distinct island worlds, claiming that spiral nebulae were distant star systems, outside our Milky Way. According to Shapley, the so-called spiral nebula were nothing more than gas clouds within the Milky Way. Shapley also placed our Sun in a corner of the Milky Way, which, according to his thinking, represented the entire universe. Curtis counted that the Sun was surprisingly close to the center of our galaxy. Both of these people were both correct and incorrect. Curtis approximated the extent of the cosmos. However, he miscalculated the position of the Sun in our galaxy. Clearly, Shapley was incorrect about the vastness of the cosmos, but he was pretty precise about the location of the Sun. We have made great strides since then. Improved understanding of the observable universe. In 1996, galaxy researchers Sidney Vandenberg and Gustav revived the discussion. Gustav Tiemann, who debated over this issue, asserted that the Hubble constant had a low value of approximately 55 kilometers per second per parsec. Vandenberg, however, presented data suggesting a higher value of the Hubble constant, 80 kilometers per second per parsec, indicating that the universe may be younger and more compact than previously believed. Constant is the unit of measurement used to communicate the expansion of the cosmos to the uninitiated. Since the Big Bang, when the universe was created, the universe has been expanding, and its expansion is accelerating as it grows. Tiemann did, however, present some compelling arguments. Each had facts supporting their position, but neither was able to convince astronomers of the opposing view. Even today, 25 years after that argument, astronomers are unable to agree on the cosmic distance scale due to assumptions and a lack of sufficient data. Yet, based on the current data, astronomers can establish certain constraints regarding the universe's size. Astronomers are able to study galaxies more than 13 billion light-years away from Earth due to the enormous telescopes available today. Our current visible cosmic horizon has a diameter of around 26 billion light-years. However, it is undeniable that the cosmos should be considerably greater than what we can observe. If Alan Guth's 1980 hypothesis is accurate, the cosmos must have expanded so rapidly in its first moments that it grew from the size of a subatomic particle to the size of a softball in a matter of seconds. If inflation actually occurred, then the universe is far larger than we should predict based on existing data. This is where things turn, for lack of a better description, wonky. According to our film, the Big Bang was a wide event. Link the following description. We explained that the Big Bang did not take place in a single location, but rather everywhere. Hence, bearing this in mind, if inflation occurred in the first moments of time and space, it should have occurred in several locations, if not everywhere. Here indicates an unlimited number of locations. Many of the locations where inflation contributed to the expansion of the universe may reside beyond our cosmic horizon and the space-time continuum's boundaries. We are thus, therefore, either our universe is actually limitless, or there exists a cosmos beyond our comprehension. Andromeda, the nearest galaxy to the Milky Way, is approximately 2.5 million light-years away from us. When we try to see what's going on in there, We are actually looking at what it must have looked like approximately 2.5 million years ago. We have no idea what an Rose galaxy looks like now because the light cannot travel faster than the speed of light to reach our galaxy. 2.5 million years pass between the instant light is emitted and when it reaches our sight. More distant galaxies appear as if they were tens of millions, hundreds of millions, or even billions of years in the past as we observe them from greater distances. As we gaze further away in space, the light we see from the cosmos originates from its younger days. And as we've continued to seek answers to whatever light has afforded us a glimpse, we've discovered light that was emitted all the way back. In the beginning, the cosmic microwave background or cosmic microwave background is the residual glow that was emitted by the Big Bang. We also discovered that, with the exception of a few locations with varying densities, the universe was perfect. These non-uniform regions made up less than 1/3 of the universe. But for our universe, which is so huge, this amount of space was sufficient to generate the stars, galaxies, galaxy clusters, and cosmic voids we observe today, and the space curvature is shockingly flat. If this were not the case, distant lights would converge or diverge. Instead, light always travels in its original direction, despite the changes we experience and the fact that we are imperfect indicators. If the universe were finite, it would have to be at least 250 times larger than what we refer to as the observable universe, according to the information gathered. Due to the fact that we inhabit a three-dimensional universe, 250 times the radius corresponds to 250 to the third power times the volume, or more than 15 million times as much. That is almost 11 trillion light years in every direction. Despite its size, this is still infinite. Consider whether the universe has a boundary and what lies beyond it. There is grounds to assume that the cosmos may currently have no edge. We are confident that the Big Bang initiated the universe as we know it. What if, though, time and space existed before? We are aware that before the Big Bang, the cosmos was composed solely of space's inherent energy. In addition, it was expanding at a steady exponential pace, a phenomenon known as cosmic inflation. This also generated space so rapidly that the Planck length would be expanded to the size of the observable universe every 10 to the minus 32nd second. It is true that inflation in our region has ended, but we still need an answer to 3 questions. First, how large was the post-inflation region of the cosmos that spawned our hot, large bang? Correct. Number 2 is the concept of endless inflation. How long did inflation persist prior to its termination and the Big Bang? Explaining the answers to these questions would necessitate an entire video on its own. We know from our best observations that the universe is vastly larger than the portion we can witness. Beyond what we can see, we strongly assume that there's plenty more universe out there just like ours, with the same laws of physics, the same types of physical cosmic structures, and the same possibilities for sophisticated life. However, a single universe or numerous universes, or if you like to call it a multiverse, whatever we would discover at the end, shouldn't be limitless unless inflation continues for an unlimited period of time. Origin of the universe, immensely vast. The cosmos should have a limited size, but to obtain the accurate answer, we may need to expand our reach beyond the observable universe, as the answer may be encoded elsewhere in the universe itself. The possibilities are infinite and beyond.